Welcome for another physics lesson. We're going to discuss gas laws, and in this lesson we will focus with what we call the pressure law. So we are beginning with the first question here. State the pressure law. State the pressure law. So the pressure law of an ideal gas states that for a fixed mass of a gas, volume, pressure is directly proportional to its absolute temperature, provided volume is kept constant, or rather at a constant volume. For a fixed mass of a gas, pressure is directly proportional. So keywords are directly proportional, then absolute temperature, not just temperature, absolute temperature, directly proportional. Then we are told in another question here to explain how a gas exerts pressure. How does a gas exert pressure? Remember, the molecules of a gas are at a constant motion. Therefore, the collisions between the container and the gas molecules now results to pressure. Therefore, the collisions between the gas molecules these molecules are in a random motion, which are in a random motion, collisions between the gas molecules and the walls of the container. Result to pressure. Result to what we call gas pressure. So gas pressure is as a result of collisions between the gas molecules, which are in a random motion, with the walls of the container. Then we can look at another question here. We are told that the figure below shows a setup used to verify pressure law. Then we are given a setup here whereby there is a thermometer. This is a thermometer. This is hot water. This is a stirrer. The stirrer is to ensure that the heating is uniform. Then we have dry air in a glass flask. Then we got a Bourdon gauge. An alternative apparatus which might be used instead of Bourdon gauge to take pressure readings is what we call the pressure gauge. Actually, in some settings, people will not tell you that, the examiner will not tell you the setup is used to verify pressure law. They will tell you to verify a certain gas law. Then the first question will be, you state the gas law being investigated or being verified. When we examine, you can see a Bourdon gauge stroke a pressure gauge, which is used to measure pressure. So knowing that pressure is among the quantities being varied here, and again we can see a thermometer, meaning that temperature is also in place, then it means we are examining pressure law of an ideal gas, which compares pressure and absolute temperature. State the measurements. This is supposed to be measurements that may be taken in the experiment. What we need is temperature, or simply thermometer readings. Then we have pressure. Then you see the water is hot. So at the beginning of the experiment, we are having very hot water, but given time, it will continue losing heat. This is different from a case whereby we are heating the water, whereby temperatures will be increasing. In this case, they'll be decreasing. Therefore, we are taught to explain how measurements in Roman 1 there can be used to verify pressure law. And what we do is that you record values of pressure with the corresponding, it's what we call corresponding values of temperature. With corresponding values of temperature. Then you tabulate several pairs and plot pressure against temperature. Yes. So what we do, we tabulate, or we put in a table several pairs of the values, each pressure and corresponding value of volume, not volume, sorry, temperature, sorry for that. Then you just tabulate. Tabulating is putting in a table. Then now you plot for us what you call a graph of pressure against temperature. Then now what we expect here is a straight line. A straight line is obtained. A straight line is obtained showing that pressure is directly proportional to absolute temperature, hence pressure law verified. Hence pressure law is verified. So that is how we use the setup to verify pressure law. You first record values of pressure. Remember, temperature is varying. So at a particular time, temperature will be different. So each value of temperature should be accompanied with the corresponding value of pressure. Then you tabulate the several pairs of values, a pressure corresponding temperature. Then you plot now pressure against temperature. After plotting, we expect a straight line showing that pressure and temperature are directly proportional, and hence pressure law is verified. So we can go to the last part of this question. We are told that a car tire is at pressure of 5.0 times 10 power 5 pascals at a temperature of 37. This is 37 degrees Celsius. While it is running, the temperature rises to 75 degrees Celsius. What is the new tire pressure? What is the new tire pressure? Assume the tire does not expand. In other words, at a constant volume. At constant volume. That is the language, in other words. In other words, the tire or the air in the tire is obeying pressure law. And therefore, we say the pressure is directly proportional to absolute temperature. That means pressure equals to a constant times temperature meaning that for us to get a constant, we need pressure out of temperature. And when you take a sample of a pressure, sample of a gas, a fixed mass, then you heat, we expect temperature and pressure to give us a certain constant. Even different values of temperature and pressure should be able to give us the same constant. Now that the graph gives a straight line, and it means that at a different pressure, the ratio of pressure and temperature is just the same, even if you change the values. This gas is obeying the pressure law. Therefore, it should be again noted that we are talking about absolute temperature and not temperature in the Kelvin, not temperature in the Celsius scale. So the first pressure, 5.0 times 10 power 5, divided by the first temperature. So I should take 37 and I add 273, giving me 310 to get Kelvin, equals to pressure 2. What is the new pressure? So pressure 2 is unknown out of temperature 2, which is 75. So I should add 273 to 75, giving me 348 Kelvin. Therefore, to remain with pressure 2, I need to multiply by 343 both sides. So this by 5.0 times 10 to the power of 5. Then now I divide by 310. This gives me 5.61 or 62 times 10 to the power of 5 pascals. So that is how we get the new pressure. Thank you for following. Subscribe and share.